Hi there, welcome to a Playcraft digital logic tutorial. I am your host, Will Patillo, and I'm going to be using some simulator / game software that my dad and I created called Zombie Gates. Now this is from level Boolean Logic 3, which is a somewhat complicated one, but I'm going to walk you through it step by step so that you can take pretty much anything this game throws at you and not be intimidated by it. So here's the equation that we're working with: A naught, B naught, C, D, or A, B, C naught, D, or A naught, B, C naught, D, or A, B naught, C, D. That's quite a mouthful there, but equations like this we can just start by working with the things that we know that'll just always be present, and then get into the specifics partway through. So I'm going to start out by just taking each input, bring it out a little bit so we can use those, and I'm going to split each of these. So sometimes I'm going to be using the true condition, and sometimes I'll be using a false condition. Should put those inverters down right now. Right. So every time I want to use A, I can just pull it off of this branch. Every time I want to use not A, I pull it off of this branch. Same for B, C, and D. Now another item I can just get out of the way right now is there's four equations here, and each of those, so when you see two letters right next to each other, that means they're multiplied, which equates to an AND. So that means four AND gates, one for each equation. And those AND gates are all going to get ORed together. So I get some ORs out here. Now I'm working with gates that only have two inputs. So, if I had four, I could just put one of those down and take all four ANDs right to it, and I'd be done. But since I only have two inputs, I need to work with what I have. So I take two ANDs, put it to one OR, the other two ANDs, put it to another OR, take these two ORs and put it to that OR, and that's effectively the same as ORing all four of these. So these are my pluses right here. So I'm just going to go ahead and wire those up. So take these top two ANDs to this OR gate, bottom two ANDs to this OR gate, put these two OR gates to the last one, and then my final OR gate goes to the output. Right, now next, similarly, with the fact that I'm only working with two input gates, and each of these equations I'm ANDing four inputs together, so I'm going to need an intermediate step where my first equation needs two AND gates, and these both go to this AND gate here. So this whole setup is my first equation. So here's my four inputs, and AND those together. So this is effectively like a four input AND gate, this arrangement right here. So I'm going to repeat that again for my second equation, and for my third equation, and for my fourth. So 1, 2, 3, 4, 5, 6, 7, 8. Good. So here's second. Here's my third. Oh, went a little far. That's all right. Bit of extra wire. No big deal. And there we go. All right, so there's some of my front end stuff. Now, so I can just take first equation, put all of them into these four, second into these four, third into these four, last into these four. It'll make more sense as I go. So let's look at this first equation here. First I have A naught, B naught. So I just go from my NOT gate. Here's my A naught. And here's my B naught. That's right there. Now I have C, D. So I'm using the true conditions in C and D. That's no problem. I'll just take my C is right there, and my D is right here. Just taking these one step at a time, be very systematic about it, and you won't make a lot of errors. So now I'm able to move on to my next equation, AB. So let's see, it's a true condition for A. And now true condition for my B. Let's just take that right up to here. Okay. C naught D. Okay. Get the naught branch of my C. And D, so I'm using the positive condition again. I'll just throw down another connector because it's closer and more convenient. Okay. All right, now I'm on to my third equation, A naught B. All right, so here's the naught for my A. I'm going to split that because I need it. Take this down here. Okay, and B. Let's see, I'll just split this wire here. So anything connected to this true branch, I could go from here, or I'll go from here. Okay, second half of my third equation, C naught D. Okay, here's my C naught. Okay, put this over here. And D, all right, I'll just use this branch some more. Okay, and my last equation, AB naught. So I'll go from this branch. Actually, I'll just split a wire there. It's still part of the true, so I can use it. So I'll just take this all the way down, and I'm just going, wherever's convenient at this point. There's not much method to how I'm organizing these branches. Where was I? Oh, I just did the A, so now B naught. Put that here. Bring this down, across, and C D naught. Okay. So I'm using the positive side for my C. I'll branch this off. Take this over here and down. And D naught. So I'm finally using this. If there were no D naughts, I still would have made all these positive and negative branches, and then when I realized at the end that I wasn't using it, I would have deleted it. Just follow the process every single time and then get rid of what you don't need rather than having to think a whole lot about it in advance. Alright, so this is a bit of a complex bit of wiring I have in this middle section here. This bit's simple. Knew it from the start. This section over here isn't too bad either, neither is this. But this part here, looks kind of confusing when you're finished. But just remember, it was just looking at one letter at a time and sending it to the appropriate gate, working my way down. So now let's see if this works. I'm gonna run this, and again, my goal here is for the output to be off whenever I have a row of smiley faces stepping on the buttons, which will then turn these inputs on, and for the output to be on whenever I have a row of zombies passing through, so that I can, let the humans get into shelter and kill the zombies before they get in. So I'm gonna run this, see what happens. See if I made any mistakes. Sweet. Die, zombies! Haha! Got him. Almost. Aha, yes, I got it. So, yeah, no mistakes at all, despite this fairly complicated equation and all this work here. Just, going through it systematically and keeping track of where you are. And it's, it doesn't matter how complicated it gets. You can still work your way through it. So, there's one question left to be answered on this, is suppose you just had this truth table here, and you didn't have these equations. What would you do then? Well, the simple answer is you can generate the equations from the truth table. So, how would you do that? Well, I'll just start at the top here. Basically, the way you can think about these Boolean logic equations, particularly sum of products, is that each section of it, divided by these ORs, is one condition in which the output is true. So that means, for as an example, I take this row right here. This is A naught, B naught, C, D is a case when I want the output to be true. So that means I need to wire up some an AND condition, an ANDed condition, for this line. And I do not have to worry about any of these rows with smiley faces in them, because those are conditions when it's off. And so, since an OR gate is, if any of them go in, then the OR turns on, that means I do not want any path going into the OR gate for any of these happy faces or these off conditions. So that means I just don't have to worry about them, and I only have to look at the rows that I want the output to be true, or these rows with zombies in them. So so I look at the top here, I have A naught, B naught, C, D. In other words, when this row gets to the buttons, C and D will be pressed. That means these two conditions will be on. And A and B, there's nothing going to be pressed, so it's going to look like this. And I have an on condition right there. Again, I don't have to pay attention to this row, I can just ignore it. Or I'll just show you what it looks like. So it's only B is pressed, it's off. But again, for the purposes of building, I can just ignore that. Look at this next row with zombies in it. This is A is off, B is on, C is off, D is on. So I create a path for that. Again, so this first row here is A naught, B naught, C, D. This second row right here, this is A naught, B, C naught, D, or this equation right here, A naught, B, C naught, D. Then this next row with zombies, again, I ignore all these. This next row here is A, B naught, C, D naught, or A, B naught, C, D naught. And I can find that right. Let's see, where did I put that? Yeah. A, B naught, C, D naught. So I'd write this equation down here. And then lastly, I get this one here. And I have A, B, not C, D. And so I can just write down A, B, C naught, D. So I take those four equations as I write them down, and I just put a plus between each of them for the ORs. And that's how I get from a truth table to logic to all of my logic gates. And, with those few steps in mind, plus some of these little organizational processes I showed here, you can take any truth table that your electronics project or this game throws at you and create everything that you need. It might be tedious, it might be a little difficult, but you will be able to find the answer every single time. Now there's some more complicated things for making it simpler. This particular equation, I believe I set it up so that it cannot be simplified. Maybe it can, but that's a whole nother complicated process and would require its own video. So I hope you enjoyed that and hope you found it informative and useful both for the game and for your classes, and I will leave you there. Thank you very much for watching, and don't forget to subscribe.